Okay, so oh yeah, microphone is on. So this is the last question that I've already done, and then we're gonna be moving on to sketching the graph. And I'll work on 13, and then maybe MCQs. I think that might be the best plan to go on here, because we still need to do some more things in 11, maybe learn a couple things on 12, then 13, and then I was thinking doing MCQs with you. So for the last question, no, sorry, the second last question, the one thing that we have to do is find all inflection points of fx, if any, indicate their x coordinates and y coordinates, justify our answer. So in order for us to find the inflection points, we've already found the inflection points. We found this, remember, the potential inflection points, but they are not, we have not yet proven that they are inflection points. And how do we prove it? Well, we have to see whether or not it's concaving upward or concaving downwards. Okay, here, an inflection point will have a concave upward or will have a concave downward. It will either start from here, it will either concave upward. Let's look at the pink one. Concave upward, go down, then concave downward. That's one inflection point. And then another one is from down, concaving downward, and then it will go to concave upward. So it will look like this altogether. Concave upward, it started at the front, at the top, and then it will go down, so it's concaving downward. And then this one is from downward, and it will go concave up. So we just need to prove that these points have concave down and concave upward, which they have. So from here, right here, from here, we see that they have concave upward and they concave downward. And if we have to put them side by side, sorry, here, this is negative infinity, negative 1, square root of 3. Then we have negative square root of 1 over square root of 3, negative 1 over square root of 3. And then we have I believe 1 over square root of 3 comma infinite here. So that's what we have. So here we said that this right is concaving upward, and then as we get here, this is concaving downward. This is downward, and then this is upward again, which precisely match what we need, because we need it to go like this one here. We need it to go from, started from upward, it started upward here, upward here, then downwards. I suck at drawing, sorry. Here, upward, then downward, then I'm talking about this, upward, then downward, then downward to upward. Yeah, so these two are inflection points. You just need to write this down. I'm gonna have to erase this, and I'm just gonna have to write it down because we might need some space later. Okay. Okay, how do we write this down? We can copy Copilot. Let's see. Here. You can say this, okay? Let's see. Is there a better way we can say this? Here, we can say this. At x equals negative 1 over square root of 3, concavity changes from upward to downward. X equals to negative 1 over square root of 3, concavity changes from upward to downward. And why is it only negative 1 over 3? Because negative 1 over 3, what is negative 1 over 3, right? When we make it into an interval, it will equal to either negative infinity, negative 1 over square root of 3, and then it will negative 1 square root of 3 times comma 1 over square root of 3. So that's the only values it will equal to, while 1 over 3 will equal to 1 over 3, negative 1 over 3, and then 1 over 3, then infinite, right? So why are we saying that this thing is concaving upward to downward? Because this thing is upward. Then from here it becomes downward. On the other side, this is downward, and then it became upward. Sorry. So by this pattern, the concavity of x, when x is equals to negative 1 over square root of 3, the concavity changes from upward to downward, while at x equals to 1 over square root of 3, concavity changes from downward to upward. Okay, then this confirms, therefore you can say this confirms that both are true inflection points, because the graphs inflection points because the graph bends in opposite direction on either side. In opposite direction in either side. We need it to look like this. Basically, we need something to start from concaving upward to downward, and then from concaving downward to upward. That's how we know it's an inflection point. There's two inflection points here because it bends in opposite direction in either side. That's how we know. And now I'm gonna have to erase this. I'm so sorry, mi amor. And maybe I'm gonna have to move this because I don't know if we're gonna have enough space. So I'm gonna move it here. There, maybe. And the next step is that we have to indicate their x coordinates and their y coordinates, and we have to justify our answer. That is very simple. In order to find the y coordinate, since we've already found the x coordinate, look at the part where it has Copilot. You already found the x coordinate